Hey everyone, welcome back to the YouTube channel of Developers and Coders Club. Today we are here to discuss the problem rank queries, and in this question we will be given an array of n integers, and the rank of an index is defined as l plus 1. What is l? It is the number of indices j in the array such that aj is more than ai. That means if this is the given array, then rank of this element will be the number of elements which is more than this element, the count of elements which are present in this array and which are more than this plus 1. If the count of element is n, then that will be n plus 1. That is the rank of this uh, index. Now check needs to answer Q queries of the following type. What are the queries that he will be given K and R? K is pointing to a particular index and R is pointing to the uh, rank of that index. Now, given integer k and r, the task is to determine the smallest integer x, such that if you remove at most x elements from the subarray a1 to k minus 1 and at most x elements from the subarray k plus 1 to n, the rank of the element which had index k in the original array is smaller than or equal to r. What he want to say that if this is the given array and this is pointing to our this is the kth element. Then if we remove at most x elements from before this index and at most x elements after this index, then after that removing these elements, the rank of this element should be smaller than or equal to r. So we have to print the smallest integer x such that if we perform that operation by following that condition, the rank of this element should be equal to or smaller than r. Now understand it with the test cases. Okay. Now 2, 1, 3, 4. This is the given array. Now if we process on the first query, that is 1 and 1. This is k, this is r. So we are processing on the first index, and we want that after performing that query, the rank of first index should be 1. So what is the rank of this element currently? It is the number of elements which are more than 2, that is 2, plus 1, that is equal to 3. So 3 is the current rank of this 2, but we want to make this equal to 1. So we have to select an integer x, such that if you remove at most x element from this side and at most x element from this side, then the rank should be equal to 1. So what is our target? Currently that is 3, we want to make equal to 1. So we want to remove two elements which are more than 2. If we able to do, if we able to do this, then we can simply get a rank equal to 1. Now, if we are trying to remove two elements, then should process, we should think x such that that should be as small as possible, as well as the condition should follow that if we remove at most x element from this and at most x elements from this, then the rank should be equal to 1. Now, we know that we cannot remove any elements from this side, but so if we want to remove two elements, then we have to select x equal to 2. Because we want to remove these two elements, so we have to select 2, x equal to 2. So for this the output will be 2. Now if we select this 1 and 2, same index, but the difference is that now we want to make equal to 2. That means we want to remove only one element. Indeed, in that case we can select x equal to 1, and we are saying that if we remove at most one element from this side, like if we are removing 3, then the rank of this will be equal to maximum greater than 2, that is 4 plus 1, so that is 2. 1 plus 2, 1 plus 1, that is 2, and that is the desired rank. So for this we are selecting x equal to 1, and if we consult for 2 and 2, this is the index, and we want to make the rank should be equal to 2. What is the current rank? What is the current rank? That is greater element which are more than 1, 2, 3, 4. 3 elements are there plus 1, that is 4. 4 is the current rank, and we want to make this equal to 2. That means we want to remove two elements from this array which are more than 1. So we can select as equal to 2 here, Like if we select x equal to 2, then we are saying that we can remove at most two elements from this, at most two elements from this. And if we remove 3 and 4, then 2 and 1, yeah, rank is 2 because 1 plus 1, 2. But if you think that if you choose x equal to 1 and remove at most one element from this side, that is 2, at most one element from this side, that is 3, then also we are getting rank equal to 2. So for this case, the output will be 1. In 3, 2, this is the index, and we want to make the rank should be equal to 2. What are the elements which are more than 3? Only 1 plus 1, that is 2. So that we don't need to perform any type, we don't need to remove any type of elements. Okay. Now just tell me that if I give you to a vector of pair, what it stores? It stores two numbers. What are that? That VTR of I dot first. This will equal to the number of elements which are more than array of I, and VTR of I dot second. This stores the number of elements which are more than array of I. But this is in left side and this is in right side. I just think that we are getting this vector from a function. Use that as a black box. I will tell that how we are getting that vector. But as of now, think that you have this vector. Now what you can do? You will be given a R, and you will have current rank. How we are getting that current rank? That is the number of elements in left side which are more than this array, and number of elements in right side which are more than this array. So current rank will be equal to VTR of I dot first plus VTR of I dot second plus 1. That is the current rank. And what we want that we want to make this equal to R. Then how many elements we want to remove? That is R minus this. These are the count of elements which you want to remove, because if you remove that, then this will be equal to that R, and that element should be more than this array of I. Now how we are going to remove? R minus, just think that that is current rank. These are the elements which you want to remove. Let's call it lambda. Now if lambda is less than 0, less than or equal to 0, in that case we can see that we don't need to remove any elements, then we can print 0. Otherwise what we want to distribute this lambda in two sides such that that x should be as small as possible, as well as that also sums up to this lambda. What I want to say that we want to distribute this lambda in two sides equally. So for that what we can do, that divide this lambda by 2 in this side also, in this side also. And what will we say, that we are going to choose lambda by 2 elements from this side and lambda by 2 elements from this side. But what if the lambda is odd? Like if lambda is 6, then we can say that okay, we can select 3 elements from this and 3 elements from this. But if lambda is odd, in that case like 7, then what we can do? We can distribute it like 4 this side, 3 this side, or 3 this side, or 4 this side. So what we want to print the answer, that is the what is the smallest integer. Like if we x is that, then we want to say that if we remove at most x element from this and at most x element from this. So for this case, if I say that I want to remove at most 4 element from this side and at most 4 element in this side, then both are true. Because at most 4, that means we can remove 3 elements also. So if that is odd, then what we will do? Lambda plus 1 by 2. That will call 4. So instead, in case of even also, we can do this because that will equal to lambda by 2 if lambda is even. So now what I want to say that if lambda is the number of elements which you want to remove, then you will remove lambda plus 1 by 2 elements from left side and lambda plus 1 by 2 elements from right side. But there is also a edge case. Like what if the number of elements which are more than this element are let's call that alpha in this side and beta in this side. There can be a condition in which alpha is less than lambda plus 1 by 2. What you need to do in that condition? In that condition, what you will do that you will remove all alpha elements from this side and the all remaining elements from this side. And what you will you output? The maximum of alpha and lambda minus alpha. Are you getting that? What I am going to do here? That alpha is the number of elements which are present in the left of that element and more than that element. Then if lambda plus 1 by 2 is not sufficient, alpha is not sufficient for removing these count of elements, then what will we do? We will remove all these alpha elements and the remaining elements from right side. So that will be alpha minus lambda minus alpha, that is remaining element from this side. And we will print maximum of this because we will say that okay, this is gamma. Then we will remove at most gamma elements from this side and at most gamma elements from this side. Now the question comes that how we are going to calculating that this vector. So for that there is called a binary index. There is a standard code using binary index tree. So obviously not going to explain that code. I will put a link of GFG tutorial in the description. Check that and you will get that how we are going to this vector. So let's quickly see the code. So this is the vector which I am talking there. Now this is the query part. I'm making y minus minus because I'm not going to, where is that? I'm not going to add this plus one. So I can either add the here or I can minus one here. Because if I add here, then that will be minus one because of this. So instead of this minus one, I'm making a minus one here. So y minus one here. Then y minus left numbers plus right numbers minus y. This is the number of elements which you want to remove. Now, if that is less than or equal to 0, then we will print 0. Otherwise, what will we do? We will calculate the minimum of left numbers and right numbers. Now, if the minimum is more than of half, then we can say that we can remove at most half elements from both sides. And in that case, we will print half. Otherwise, we will remove minimum from a side and remaining minus minimum elements from other side, and we will output that. So, and this is the code which is created using binary index tree. So you can get from the GFG tutorial. So I hope you got it. See you in the next tutorial. See you. Till then, happy wedding. Bye.